Okay, so in this video, we want to quickly review how to sketch a graph of the trigonometric function called the tangent function. Now, if you recall by its definition, tangent of theta is the opposite over the adjacent, but we can also view tangent of theta as the ratio of sine over cosine. So tan of theta is the sine of theta over the cosine of theta. And if you think about this, what we have to watch out here, as sine and cosine are always defined, we have to watch out for a possible division by 0. And if you remember, cos of pi over 2 and negative pi over 2 is 0, so we'll sketch the tangent of theta between negative pi over 2 and pi over 2. And we can quickly sketch the graph of tangent of theta if we look at the three key values, negative pi over 2, 0, and pi over 2. So let's look at 0. So tan of 0, well, will give us sine of 0 over cos of 0. Sine of 0 is 0, cos of 0 is 1. So here we have 0 over 1, which is simply 0. So tan of 0 is equal to 0. Now let's ask ourselves what happens as we let theta increase from 0 to pi over 2. If you recall, as we let theta increase from 0 to pi over 2, sine will increase from 0 to 1, but cos will decrease from 1 to 0. But both are always positive. So as we let theta get closer and closer to pi over 2, sine will get closer and closer to 1, but cos will get closer and closer to 0, but always positive. So as we approach pi over 2 from the left, we're going to have here 1 over positive 0 case. But if we divide something that is closer and closer to 1 by something which becomes closer and closer to 0 and positive, well, 1 over something small is something big. So the tan function, as we go from 0 to pi over 2, will get bigger and bigger and bigger, but because sine will get closer and closer to 1 and cos will get closer and closer to 0, the fraction will grow out of bounds and will keep increasing forever. So what we have is a vertical asymptote at pi over 2. Tan would look something like this. And as theta gets closer and closer to pi over 2 from the left, the tangent will keep shooting up forever. And now we can make a similar analysis from 0 to negative pi over 2. If we let theta decrease from 0 to negative pi over 2, well, the sine will go again from 0, but now we'll get negative and closer to negative 1. If you recall, sine of negative pi over 2 is negative 1. So the top of our fraction will get closer and closer to negative 1 as we are approaching negative pi over 2 from the right. And the cosine will also get closer and closer to 0. And also positive. So around negative pi over 2 from the right, the top of our fraction is really close to negative 1, the bottom is really close to 0 and positive, so what we have is something that's really large and negative, right? If you ignore the negative sign, 1 over 0 is really big, it's infinity, but the sign is negative, so we get negative infinity. So we have another vertical asymptote at negative pi over 2, but this time, the tangent function shoots down to negative infinity. And now we have the graph of tan of theta. But only between negative pi over 2 and pi over 2, but the tangent function is periodic, so if you want the graph over the entire theta axis, simply copy-paste this up and down the axis, and you will have the complete graph of tangent of theta. And that's it.